the search engine accepts a string or a pattern from the user, then it apply a string matching algorithms to find a document that contains a pattern that's entered by the user. Okay, this is the most widely applications of a string matching algorithms. The another application is the editor. The editor means it is the editor. It's an environment that provides that provides a program that provides an environment for the programmer to edit the programs. And then now, so this edited programs are given to the compiler or interpreter to for a compilation. That's common thing. That's a common approach. So the edit the application or edit programs, so they also use the string matching algorithms to find the string that occur in a program, or to find a pattern in a program, we can use the string matching algorithms. So this is the one more applications. Then to to find the similarity between a two persons. The similarity between the two persons. The similarity between the two persons means now the P1 and P2 are the two in the individuals. Now the individual has got the different DNA sequence. DNA the sequence. So the each person has got the different DNA sequence. Now to find how these two individuals, the P1 and P2, are similar with respect to their characteristics, with respect to their the behavior, with respect to their the hobbies, or any other matters, any other the features. And for to find out the similarity between the two persons and the two individuals, so then we need the string matching algorithms. The string matching algorithms. So in this way, we can list out the n number of the applications that make use of the string matching algorithms. So today I'm going to discuss different string matching algorithms that are a part of, that is described as part of your syllabus. There are four type of the string matching algorithms are mentioned as part of your syllabus. The first is the naive-based string matching, the algorithms. Then we got next is we got the first is the string matching. There is a naive-based string matching. That then so the next is it is Robin Corp. So Robin Corp string matching algorithms. Then next is the finite automata based the string matching. Then next is we got there is Knut Morris the string matching, Knut Morris Pratt the string matching algorithms. So these are the algorithms we are going to study in this chapter. It is a string matching algorithms. Yes, please make a note of all this. The algorithms I'm going to discuss one by one. Now, basic string matching algorithms. I'm going to that is the basic the string matching algorithms is a new base string matching algorithms. Today, the first topic the first topic on the discussion is the string matching. So then I'll come off. That is, I'm going to discuss on a Robin a Corp a string matching algorithms. Yes, are you ready? Yes, are you ready? Are you ready? Yes, are you ready?
Yes, sir.
Yes, sir.
Yes. So now I'm going to lock the meeting. You should not go out, and no one should enter the meeting. I'm going to lock. Okay, I'm going to lock the meeting. Yes, yes. Yes, the first one, the first thing is the first one I could discuss about the it is the neighbor string algorithms. Now here is the prerequisite for a string matching algorithms is the first is we need a text. So then we need one more is like we need a pattern or the a string to be assessed. So the first is the string. What is the string? You may ask what is the string means. It's a sequences of a symbols or the sequence of a characters. Then so there is one more a term I'm going to use a common frequently. There is often a so that is the pattern. What is a pattern means? Again, it's a sequence of it is a sequence of a characters or a symbols. Now, text or a document. I can say a text means it's a document. A document. So a document again it's a sequence of a characters or the symbols. Character of the symbols and the text has a finite number of the sequence of the symbols. So that's why the length of this the text is n. The length of the text is n, and at the same time the pattern is also the pattern is also has a finite number of sequence of the symbols. So therefore now the length of this the pattern is the m. So where so the length of the pattern is always less than or equals to the n. It should be less than equals to n. So this is the prerequisite. Now the the symbols can be the alphabets, that is alphabet symbols, that is from A to Z. This means the symbols like these are the symbols, and the symbols can be digits, that is from 0 to 1 to 9, 0 to 9. Okay, these are the symbols. Now here is a set of the inputs. Symbols are denoted as a summation symbol. Summation symbols. The set of input symbols is denoted as a summation symbols. Now, what is this summation star indicate means it is the sequence of the input symbols that are formed from so the summation, the summation. Okay, and that's a string. Then we got a string, we say a string or a text. So how a text is formed? A text is formed by taking the symbols from the symbols. The text is formed by taking the symbols from the alphabet. In the same way, the pattern is formed by taking the symbols from the alphabets. Either alphabets can be ABC to Z or the alphabets can be 0 to 9. 0 to 9. So anything can be an alphabet. So why this alphabet is required? Because a text constitutes a set of symbols derived from a symbols. Okay, and the pattern consists of the sequence of the symbols that are derived from the alphabet. So this is the basic things you need to understand. Then, so the one more a concept is the prefix. One more a concept is the one more the prerequisite required is the prefix. So what is a prefix? The prefix means it is a substring, the substring. So for example, so the X is a string. The X is a string for which if you define a W as a prefix. The prefix is always a subset of a string. The prefix of a sub is a prefix is always a subset of a string. And the same way, if we're going to define a suffix, the suffix is also a a subset of a string. So now the prefix are indicated with the symbol, that this is the symbol, and the suffix are indicated with the symbol is like this the symbols. So now I'll make a convention. So here is the prefix, the prefix. So the prefix, like say for example, so a W is a prefix, then the length of this prefix should be less than equals to the length of a string. What is a X? X means a string, and W is a prefix. So prefix is a W, and a length of this of the prefix it should be less than equals to the X. In the same way, now there is a suffix. There is a suffix. The suffix is a substring. It's a substring. So R is a subset of a string such that, so a W, say for example, W is a suffix, it is suffix, and again it's less than equal to the length of the string, length of the string. Length of the X, length of the X. The symbol for a suffix is, this is the suffix symbol, the suffix symbol. And the symbol for the prefix is, this is the symbol. Okay, these are the annotations or the prerequisite to understand the string matching algorithms. The string matching algorithms, for the string matching algorithms are the prerequisite to be known to understand the string matching algorithms. Yes, are you ready? Are you ready, boys, girls? So yes, are you ready now?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so now let us start. Like here is a the string. The string is given as, the string is this, the string is given. So just what I do is I'm going to say the string. Yeah, there are the many concept I want to explain. So the beat me. So it is the string. Let us say this, the A B C is a string. The ABC is a string, or say the ABCD is a string. So we call this is the text. It's a text because a text, it contains the sequence of the input alphabets. The input alphabets are here, the A, B, C, D are input alphabets. The pattern is again, so the E, B, C, it is a pattern, or it's something other than that also. But now, so at present, say the pattern is consists of the symbols ABC, ABC. So the string matching algorithms, the core idea of the string matching algorithms is match the each character of a pattern with a character of a string. If the character, see now when you start the comparing a character to a character of a pattern is matched with a character of a text. So if it is match occur, then so you go for a next character match. Go for a next character match. Again, if there is a match, so if there is match again, so go for the comparing a character by character. So this is the core idea. Just here, the each a character of a pattern is compared with the all the characters of a text. So once, so there is a match. There is a match, that is the match between the characters of a pattern and the characters of a text. So then we say that it is a successful, the success, that is the pattern is the successfully compared, it's present in the text, searched in the text. So then obviously we say that the pattern is not found in the text, not found in the text. Okay, that's one thing. Now, so we say in the string matching, the characters of a pattern as a window. The characters, all the characters of a pattern are called as it is a window. Window. So what is window means? It's just a it's a window means it's a group of a characters. It's a group of a characters. The another name to be used like it is a template. So we can use a template or we can use a window. So anything is okay. Like we can use either the window or a template. So what is window? It's a group of characters, and template means it's also a group of characters. So these are the two words are used frequently in the string matching algorithms. Yes, sorry, there is some interruptions. Okay, there is an interruption now. So the first algorithm, we'll start with the first algorithm. The first algorithm is Hello? Yes, I'm audible.
Yes, sir.
You're
Yes, sir.
audible.
Yes, yes.
Yes, sir.
Okay. Yes, this is the first string. Is it visible? Is it a screen is visible to you?
Yes,
Is it
sir.
visible to you? Yes. Very nice. So our text consists of. So now after that, so a text it consists of. There are different symbols are present, and it has got 6 symbols in the text. At the same time, so this is the pattern which consists of three symbols. So it is A, B is symbols. So each a character of a text are in text. So here
Hello,
index,
sir.
yes, man.
Sir,
Sir,
the
symbols
files,
not visible, sir.
Huh?
we are
Screen.
seeing the files folder, sir.
But
Downloads
Symbols.
folder.
that's what I asked you. Is it visible? You said yes. Oh, wait. Wait. Ayo. Is it visible now? Is it
Yes,
visible?
sir.
Yeah.
Yes,
Mm,
sir.
yes, sir. Now it's visible.
Here is a text. I take a simple a text that consists of 6 symbols, and so this is a template which consists of three symbols. It is A, and B are the symbols, and the each characters are indexed. The index of a text is 0, 1, 2, 3, 4, 5, and the index of a pattern is 0, 1, 0, 1, 2, 3, 0, 1, 2. So here is it is now I am discussing the name based string matching algorithms in which you need to compare the the whole the pattern. The whole pattern means is the window of a pattern. It's a window. It's a window. The the window consists of three symbols. The window consists of three characters. So this three there is the window is slide over the text. Slide over the text. So what is a slide over the text means now? So now here is a index 0 is now it is slide over the index 0 of a text. So index 1 of a text it is the index 1 of a pattern. So index 2 of a text it is a 2 of a 2 of a pattern. So now here we are sliding, that is you are placing this a pattern, you are placing this pattern over this. So now we call as it is shift equal to 0. Shift equal to 0 because we are comparing a 0 index of a text and the 0 index of a pattern. So now therefore the shift equal to 0. Shift equal to 0. So when the shift equal to 0, then you compare a character by character. A character by character means the first character of a pattern is compared with the first character of a text. That is the index, that is a character at index 0 is compared with a character at index 0. So if it is match, if there is a match, then so increment the index of a text, the increment index of a pattern. Now, when you increment the see that's what I am saying here is the if the t of 0 is equal to the t means a text, p means it's a pattern. So if the t of 0 is equal to p of 0, then so that is the a is equal to a, there is a match. So compare the character to character. So if it is a match, so then increment the index of text and index of this a pattern. So when you increment this t of that is at index of a text that becomes t of 1, and when you increment the index of a pattern it becomes 1. So a t of 1 is compared to the p of 1. So when you compare this, now see the index of t1 is the t of 1 is contains a c and index of p contains it is A. So there is mismatch. There is mismatch. So once the C is not equal to A, there's some mismatch. There's some mismatch. So then we say that is the naive space algorithm say that you slide a window to a next position. A slide window. A slide window means now move move a window. That is, window means a pattern window. It is towards right by one position. By one position. Now, as you do that, so we can observe that. So it is the window is slide over the text by one position. So therefore, you can say that we have shifted the window towards right by one position. So therefore, you can see that S shift equal to 1 or S equal to 1. S equal to 1. See now, here is, now we have shifted the window or pattern, the window of the pattern shifted by one position. Then again compare the index, the 0th index of a pattern with the first index 1 of a text. So index 1, that's T of 1 is compared with the, so P of 0, P of 0. So you are comparing a character to character. So but here the character that is present in the T of 1 and the character that's present in the P of 0, so it doesn't match. So you can see this A is doesn't match with the C. So therefore there's a mismatch occurs. Mismatch occurs. When there is a mismatch occurs, we need to shift a pattern. Shift a pattern window towards the right by one position. So now I say it is slide the window towards a right position, towards right by one position. That is your slide the window. So again, now next we can say the next is like when you slide the window, that is we are shifted the window towards right by two position. So that's why I can see the S equal to 2, S equal to 2. So once you do this, the shift the window by two position, we get this is this is the window. Now again you compare a character to character. The index of T2 is compared with the index of the P1, and that's very P0. That is, so a T of 2 is compared with the P of 0. The T of 2 is compared with the P of 0. Is now that is a character is compared with a character, a text. So there is a match. There is a match occurs between the A, that is the character of pattern, and character of a text. There is a match. So match occurred. So when there is a match occurs, the increment index of a text increment the index of a pattern. So once you increment the index of X text and a pattern, that means you now you're comparing a next character, it's A is again compared with the A, that is a T of 3 is compared with P of 1. So earlier it's T of 2 and it is P of 0. Now it is T of 3 is compared to the P of 1. So when you compare this, so there is a match because of the A, that text of that's P of 3 is equal to A and the P of 1 is A. So therefore it's a match. So once there is a match, again the increment the indexes of the text and the pattern. So when you increment indexes, we can see that's T of 4 it is. So earlier it is T of 3, now it becomes T of 4 is compared to the P of 2. The P of 2, this P of 2 is 2, and P of 2 is B as compared to the, so T of 4 it is B. Now there is a match is here, the match is here. So now here is all the characters of pattern are matched to the text character, a text character. So that is the E is matched to the E, and the E of a pattern is matched with the E of a text, and B of a pattern is matched with the B of a text. So you completely matched all the characters are pattern in the text. So once it is found that successfully if you able to compare all the characters of a pattern in the text, so then we say that so this pattern or a string is present in the text, or a string is present in the document, or when you go do a Google search, when you search in the particular a document with a keyword or the string, If that string is present in that document and set of documents which satisfy this condition will display as a result. So that's how the Google search engine to work. It's a Google search engine. It's a string matching algorithms. It's a string matching algorithms which accept a string from the user and compare that string in all the documents that is present in the database. If there is a match with the match to a string in the document, then that stuff document that has a match so is displayed as a result. So now these are the let's compare character, compare the character so that we can see in the figure. You can see, and so hope that now you got a basic the idea of the how the string the pattern is compared with the text. Okay, so now with this we understood this, we are going to write a sort of code for the Naive based algorithms. Have you understood this?
Yes,
Have you
Yes, sir.
understood? No. Okay.
sir.
Yes, ma'am. Yes, ma'am.
Sir, this AAB is taken as random string, no, sir?
Anything. This is the user specified string. The user can specify the any string as he wishes. He can specify it is a AAB or can be BBA or can be just AAA or can be 3 characters, F4 characters. It is user defined pattern.
Okay, sir.
Okay, that is to illustrate the concept. I've taken a simple text and a simple pattern and simple text. So now here the pattern can be, it can be just it can be the n equal to and say m equal to 100 or yeah, the m can be a 200. Okay, so any length, but it should be finite number of elements should be there. It cannot be infinite values. At the same time, the characters of the text should be a finite number of characters. You cannot be a text. A text cannot contain the infinite number of characters. Is it okay? Did I answer the question?
Yes, sir.
Okay, fine. Very good. So next, let us see. I just stop here. I stop here. Then I'll, with the help of you, all of you, I'm going to start writing the that is I'm going to start writing the pseudocode. So the is the S. So what does S indicates? The S is shift or S. So then we know that the pattern length is M, and you know that the text length is N, the N. Okay, so the maximum like here, so we can have the following statement: the I is equal to u to 0 to, so I say it is n minus m, listen why it is. So just now we can, so and just now we saw that it is yes, just now, wait, just now we saw that here is a, so here is a text, so here is a text, and it's a shift. The only shift you can find in the figure, we can say there is a shift equal to 0 and shift equal to 1 and shift equal to 2. So is it possible to have one more shift? Is it possible to have one more shift? So let us say, example, this B is not a B here. Let us say the C it is a C. So what do you do there in that case? I repeat once again now. So in place of this B, if there is a C the C occurs. What do you do? In place of B,
One more shift, sir.
yes,
One more shift, sir.
One
yes,
more shift.
fine. Yes, very nice, very nice. Now that means if there is a mismatch at last character, we need to make it one more shift. Then my question is, the how many number of shift we can do when you compare this pattern to the text? How many number of shift, maximum number of shift you can do? with respect to this figure, with respect to this figures, how many number of shift you can do?
N minus M, sir.
S n minus m. What is n here? It is n equal to 6. So what is m? M equal to 3. So 6 minus 3. 6 minus 3. How many? 6 minus 3 is equal to 3. So that means you can have, so a 3 a shift. The 3 shift. The 3 shift means now here is a shift. Here actually we are not done any shift here. Just it's shift equal to 0 means there is no shift is done here. But you can see there is shift 1 and the shift 2 and the one more shift as I said. So these are the shift can be performed from 0 to so n minus m, correct? So that means we can do maximum number of shift. The shifting of this pattern, okay, that is the n minus m, where the n is the length of a text and m is a length of a pattern. So with this notations, I'll come back to this, that is a whiteboard. So now it is we got it is for I equal to 0 to m. So shall I write this I in place of I? Can I write this s? Can I write this s? Can I take this s? Yes, I'm audible to you. Can write in place of
Yes, sir.
yes, you can write here now. So what I do is, see now I'll compare. So a text. See I'll compare. So the character of each character of a pattern. That is, so p of 1 that's 1 to m. So why it is 1 to m? Why it's 1 to m? Because the pattern contains the m characters. The pattern contains m character. So now I'm going to compare with a text. So how do I compare? Means now it is s plus 1. What is s plus 1? So what is s plus 1 here? The s plus 1. What is s value? S value? S value?
0.
0. So 0 plus 1, it is 1. So that means now the pattern, if the pattern contains, this is say this is the text. Okay, now so your pattern, so let us say your pattern here contains, so index in place of, see now index starts from 1. The index starts from 1. I'm not starting the index with the 0 here. I will start with the index 6. So then I have got, so now here is the pattern, here is a pattern where the index of the pattern also not starts with the 0, it starts with the 1. So this is the 1, okay, it starts with the 1. So this is the text and it's a pattern. So s equal to 0, the s equal to 0 means, I'm not done any shift here, So but what I have to do, you see when s equal to 0, I have to compare the indexed 1 with the character that's indexed 1 to the character indexed 1 at the text. I have to compare that. So then I have to compare this, correct? I have to compare this. Then I have to compare this, correct? So that means all the characters of M, all the characters of the pattern to be compared with. So compared to the text. So like here, I'm going to come. I see. I compared this. If it is equal, the first one is equal, then I'm going to compare the all other characters. So in this way, I have to complete. I have to go till how long? How long I have to complete? I should complete with the s plus m plus 1. Sorry, s plus m. Is it correct? Logic is correct. So that is, I'm going to compare the pattern of all the characters is compared to the text character. So if it is match occurs, then a print a statement saying that the pattern is found. If not, the pattern is not found. Do you understood this? Here, I'm going to trace now. So what is s? The s equal to 0, correct? The s equal to 0. So substitute 0 here. So that means the p of 1 is compared with the t of 1. The p of 2 is compared with the t of 2. Then the t of 3 is compared with the t of 3. And p of 4 is compared with the t of 4. And t of 5 is compared with the t of 5. So in this way, each a character to character is compared. So now if there is no, is the S is not valid means you don't find a match. So then S should be incremented to 1. S should be incremented by 1. So in that case, the S becomes 1. The S becomes 1 here. So now see, the P of 1 is compared with the T of 1 plus 1. So T of 1 plus 1 means you are comparing the second character with the first character. Okay, then so a second character of a pattern is compared with a third, correct? And next third character of year is compared with the T of 4. Then so T of 4 is compared, the P of 4 is compared with the T of 5, and the P of 5 is compared to T of 6. When it is S equal to 0, S equal to 0. Next, then so when S equal to 2, the S equal to 2, you substitute S equal to 2 here, that becomes a 2, and here is also 2, then a 2 plus 1. So 2 plus 1 means, so now yes, 2 plus 1 means is 3. So this is the first index, and again please observe that, see, we are every time you find a mismatch, you are shifting or there's you're shifting this, say let us say this is called as J and this is called as I value, you're shifting this J value to always to the 0. You're shifting this, resetting the J value to a 0. So that is you're comparing 0 to a third character. That is, we're comparing here. I just to make a just erase here because it's too much complex. Yeah. So now, so we can see that. So we can see that here, the when you compare the third character of a text is compared with the third character of the text is compared with the, so a third character of the comparison at 0, that's P of 1, the P of 1. So the P of 1. So the P of 1 is, yeah, yes, is this the one I'm saying. So now here we are going to compare. So this is compared here. This P of 1 is compared with the, so T of 3. Then again, so if it is match, then again, so next is your increment the I value of I. So index of an T and index of P. So there is second character of a P is compared to the fourth character of a text. Like if it is match, then you have to go for next character. You have to go for the next character. See, once it is match occurs, then we are going to slide. Want to slide. We are comparing a next character. We are comparing next character of a next character of T with a P. So if it is mismatch